Hallo zusammen. Ihr habt sie wahrscheinlich alle gesehen.
Englisch?
Hörst du mich?
Ja, aber
Ja.
ich mache das später auf Englisch, das weißt du, ne?
Bitte?
Das auf Englisch haben wir gerade.
Ah, danke. Sorry, let's do it in English. Thanks for the note. Yeah. You may have seen the signs that say use more bandwidth. That means someone actually looks at the bandwidth. And Elisa has done it for the Amsterdam Internet Exchange and also here in the Congress Network. And Amsterdam Internet Exchange is the biggest IX in the world. And she will give you the insights on this. Please, an applause for her.
Wow. Okay, thank you. Yes, so I'm going to talk about sflow and traffic analysis. I'm working for the Amsterdam Internet Exchange, and I was looking more at traffic statistics we cannot normally do with other tools that are out there. I also use the software now on the conference here, so in the end we're going to see some graphs from the traffic in this conference building from the last couple of days. And one thing up front, I would really like you guys to interrupt me if you have a question or want to ask something, because I do prefer to have that in between when the question is there and not at the end in the question and answer thing. So he knows, and he's going to run around with a microphone during this talk. Okay, so first I'm going to explain what this sflow thing actually is. Then a little bit about the Amsterdam Internet Exchange, because the software I wrote to analyze the traffic there was kind of specific for this network and for the topology of this network there. So we might need to know a little bit about that. Then I'm going to explain something about the existing software which is out there and why we couldn't use that and why we, in the end, decided, because of performance issues, to write our own software to analyze the sflow data. And there are some points about privacy. You might want to know what we actually do with all the data we get and how many of that we analyze. And of course, some pretty nice graphs in the end to see some results of all these things. Okay, so sflow is a sampling mechanism implemented on switches and routers, which is sampling packets going over the network. You can sort of compare it to Cisco's iOS NetFlow, but not exactly, because NetFlow is flow-based, and sflow, even if it's called sflow, it's not really looking at flows, but it's only looking at packets. So you only get packets sampled you can analyze after that. So it is a statistical analysis. And that's why it is applicable to high-speed connections, and you cannot do NetFlow anymore on 1 gig ports or higher. So that's why we are using sflow to do that. The sflow datagrams collected on these devices are sent out via UDP to a central server, and on that server you have to have a collector software which is doing the whole analysis thing. The package format, how the sflow datagram looks like when it's transferred to the collector, is defined in an RFC, and it's an open standard, so quite a lot of vendors implemented that on their hardware, like Foundry, First 10, both of them we had here in the network as well, and some more. There's a list on the sflow website who exactly implemented that and which devices. So I'm going to show you a little bit about the datagram format. I know it's really small and you probably cannot read that, but just to see what is actually in this datagram. So we have like normal packages, some sequence numbers and some versioning stuff, and we have an IP address where this package is actually coming from. So if you have a lot of devices, you know where it belongs to. And then in one datagram like that, you can have multiple samples. So these samples are up to 10 samples, I think, or the datagrams I've seen have up to 10 samples packed in one datagram. And these samples can be two different things, because even if it's sampled sflow and everybody's explaining that like, oh, we have statistical analysis, it's not only statistical information. The statistical thing are the flow samples. The flow samples are really sampled from the packets. The other thing, the counter samples. I'm going to describe that a little bit more. So you define a sampling rate, how much packets you would like to see from the device, like 8K or 4K or 2K or whatever. And then you exactly get one out of this, and you can do your statistical stuff on that. It can provide the whole captured packet, depends of course on the packet size of the sample packet. It's limited up to 256 bytes, but if the packet is smaller, of course you also get payload information which is in that packet then. So that's the flow sample. What should I explain from that? So packet data, that's actually the important thing, because in the packet data here, that thing, you get the sampled header information, and that is not, it's not changed. It's exactly the same format like a TCP/IP packet. It's just packed inside this sflow format. So to analyze this packet data in the end, you need different analyze to decode usual IP headers and TCP headers or UDP headers or whatever. So it's exactly the same thing which is usually out there. And the counter samples are coming on time-based, so you can define a time frame how often you would like to have counter samples. And counter samples provide exactly the same stuff which is usually pulled from the switch for interface analysis now, octets, packets, errors from these interfaces. So the counter samples are not statistical at all, and you can do with sflow the same graphing stuff MRTG is doing right now via SNMP. So that's what is inside the counter samples. Packets, octets, errors, broadcast, multicast, and all the usual stuff which is stored in the interface counters of a switch, for example. Okay, so that's basically the packet structure, what sflow is, and to do something useful with sflow, you need to have a device which is exporting sflow data, and you need to have a server collector to do analysis on that. And that's, in the end, all you need to process this data somehow. Let's say something about the company where I actually implemented the software. So the Amsterdam Internet Exchange is a non-profit organization, like the name said, based in Amsterdam. And we have 4 co-locations where we connect members, customers to the switches located on each location. And we only operate on layer 2, so people put their routers behind our switches there. And we interconnect, in the end, these parties, and they can exchange their traffic over our platform. So we don't have anything to do with the peering agreements these guys have or all the layer 3 stuff they do. We only have the cables and the infrastructure, the switches, to interconnect them in these facilities. It looks a little bit like that. These are the 4 co-locations. We have 2 core switches, and around these core switches, we have multiple end user switches, to say so, connected. It's a redundant topology, so there's always only one core switch is working at one specific time. So you have either the blue lines or the red lines being active. And in the end, the people connected to these switches on the bottom or to these switches on top, there is a point where you have to sample the stuff, or where you have to sample the data to analyze it. What we do statistically right now is total traffic statistics from all the switches connected together, from the interface counters, MRTG stuff, pulled from the switches. That's basically it, no sflow. And the thing is, by looking deeper at packets, and not only at counters, you can do different stuff. You can analyze for different things, like, for example, what I'm going to show later is analysis about how much IPv6 traffic did we have on this conference or at the AMSIX platform. And that's something you just cannot do with interface counters. So it is, in the end, for different purpose to analyze packets like that. The challenge to do that at the Amsterdam Internet Exchange was the amount of traffic. This is the current traffic graph from AMSIX. We do up to 220 gigabits per second in peaks, and you get quite a lot of data to process. So that was something I had to figure out when I started working on this project, how to do that and how it is even possible to calculate in numbers like that. And the first plan was to provide member-to-member information, because if you look only on the counters from each interface, you know how much traffic one person is doing on this port, but you still don't know where this traffic is actually going to, and people are interested in that. They don't know that, or they might know that by themselves if they do their analysis on their side, and we are only in the middle, so we do not really work with all the parties connected to the exchange. Yes?
Are actually the customers requesting this information from you?
Yes, they do.
Can you please ask your question again?
Okay, I was just answering or asking if the customers are really requesting this from
Yes,
AMSIX.
Especially small exchanges, they don't have enough resources to do analysis like that by themselves.
You mean smaller ISPs?
Smaller ISPs, exchanges, sorry, ISPs, and smaller companies, they're just happy if we can provide information like that and if they see what's actually going on. Yeah, so they were requesting that. So yeah, the peering information for each member. It was the thing how we can do that on the Amsterdam Internet Exchange is that we have one or multiple ports per member, but we have a rule of only one router or one MAC address connected to each port. So you basically can filter by MAC addresses whose traffic this is what you actually see in that moment. So that was kind of helping out in determine where the traffic, to which member this traffic belongs on the way. Another thing we were sort of interested in the beginning is to see if we actually do some IPv6 traffic on the exchange or if there is some IPv6 traffic out there. So that was the second thing I implemented to analyze that. And yes, we needed a really efficient system to process that. So the existing software, which is available, a couple of them are listed here. Let me say something to each of them. So sflow tool is not really an analysis tool. It's just a command line thing where you can receive the packets and you see output to standard out what's actually coming in there and what is in the sflow samples. Of course, if you don't have a lot of traffic, you can put some scripts behind that and just parse it to somewhere, but that was not an option for our case. The other tools, PM-Act and sflow to MySQL, I've tested all of them in the beginning, so they all have this approach of we receive the data and we first save it to databases or whatever, and later on we can run analysis over these databases. But if you want to make a system more efficient than that, you could just do it the other way around and analyze it up front and then only save the data you already analyzed somewhere to a database or whatever. So that is pretty much the biggest difference in all the software which you can just download somewhere and the software I lately wrote at AMSIX. The commercial tool Inmon, I haven't tested that. It's commercial, so I don't know how exactly it's working, but I've heard rumors as well that they're processing each packet, storing it, and that it's not really scaling on a bigger platform. Yeah, so the issues in the end I had with the software was that each sample is stored, and even if you have, even if it's sampled, I mean, we have, and that's actually on the next, I go back in a second, when we have 35 million packets per second with a sampling rate, I think of 8K or something, I don't know if I even counted that correctly, you still have 3,500 samples per second you have to write down somehow, and that is quite a lot, and that is, it was not easy to do that. So that's why, back? Yes. Yeah, so that's why these options to use some of these programs were not doable. So the ideas we had was to pre-process that up front, and another thing is you want to see graphs in the end. You don't want to see tables of databases with numbers in it, fancy, shiny graphs showing you something about the traffic. So almost everybody was using RD tool in the end to make some graphs out of that. But in the end, RD tool is a database again. You don't really need to store that in MySQL, Postgres or something and then put it again into RD files, and you have the data, you have to save it twice. So we thought something up to first analyze this stuff and then put it directly into an RD database to reduce the overhead we have through sampling to writing this things twice. Okay, into that. So I started writing this software, and we were discussing for a while what we should do and how we should do that. And in the end, we figured all the tools out there, all the open source tools are written in C. And in the end, we thought, yeah, let's have something we can, I don't know, which might be for some people, I don't want to say anything wrong, but we decided in the end that it might be for us easier to have something in Perl, which we can easier script or do different things with it, different analysis types, and so on. Perl is kind of flexible because a lot of modules are already there. You can just open your UDP sockets and things like that, so you don't have to rewrite all this stuff. But one thing was missing, and that was the sflow decoding module. So we had to start out with writing a module to actually decode the sflow data. Basically the datagrams I was showing earlier. Yeah. So this NetSflow thing is open source and it's on CPAN. We published that a couple of months ago. It has only one function, decode, and you can put a sflow packet in there, and it's returning a structure of arrays and hashes with all the information which is actually in the sflow sample. It was kind of difficult because there's a lot of stuff in there, and the documentation is basically 5 pages out of what kind of hash keys you get back and how you can, and what kind of information you actually get. And there's quite a lot, but it's still useful because it's quite handy to have that in a structure. You can just go through and put it somewhere again. So that was the first thing, and that was working a couple of months ago. So then I had to go on, and I wrote a sort of a daemon around it, which is not really, it's not open source yet and it's not finished yet, but we're working on it. The thing is, it's quite hard to make that more usable for everybody. It's specific for the type of analysis we are doing on the platform, and it's, I'm still thinking about some ways how to make it more usable for other people as well. But it always depends on, for example, not everybody has this the structure of one MAC address per port, and we filter by MAC addresses, but some other exchange or some other company might not be useful for them. Like it was here on the Congress, that it didn't make any sense to sample or to filter the traffic by MAC addresses. So I have to think something up how to make that more usable. So I'm receiving the packets there, I'm analyzing them, and this thing is automatically putting it into RD files, so we don't have any other databases and in between. And it was quite nice performance-wise because we have way less I/O due to the pre-processing. And yes, Perl unpack is kind of a bit slower than C, but it's still way better for our purposes than all the other things out there. Just to have a look at that's the CPU graph from our collector server running on AMSIX. And it depends on the amount of packets or on the amount of samples you get in the end, how much CPU we're using. But we can deal with that so far. So. Dan, yes.
How many samples per second are you actually receiving with your program
You
implementation?
came late. I already mentioned that. I think we have 3,500 up to 4,000 samples per second right now. And with the total packet rate on the exchange is up to what was in there? 35 million packets per second, and we sample with a sampling rate of 8K. So of course, if you double or lower the sampling rate, you have twice as much samples, and then the CPU would go up again. But I do have some results about the accuracy of this stuff in later on, and it's quite amazing. So we don't really need to have a higher sampling rate, a lower sampling rate to have more samples right now. Okay, let me say some things about privacy. So we have this whole packet header in the end, and okay, it is statistically, and you only get 1 out of some samples, but still you could do some payload analysis on that. So the thing is, we at AMSIX we only operate on layer 2, so we didn't really want to decode more. So in the end, this net sflow module is not really returning anything more. I'm only decoding the packets up to layer 2, and of course the whole packet data is in there, and it's not too difficult to rewrite it that you have the whole structure, and then you can just decode that by yourself. But we just decode the Ethernet header, and that's in the end all we need for that. And another thing is, by not writing all the data down into a database, we just don't have all the information. It always depends on what is actually in the code right now and what we want to analyze to have it. So we don't store the whole packet, and we cannot look later on at the payload or stuff like that. If we decided now to not have more than layer 2, and we only have the layer 2 information in the RD database files, and that's it. So everything else gets like thrown away immediately after it arrives in that software. Same for this conference here. We are going to see the graphs later, so I added a couple of more things how to analyze this data, but in the end everything else gets deleted. Not even deleted, because it was never really there. So. Okay, shiny graphs. Okay, a couple of graphs from the AMSIX, and in the end I'm going to show the conference graphs. Multicast traffic. So I'm filtering by multicast traffic, and if somebody is doing something wrong on a platform, even though I have to admit I haven't figured out what that was, but it stopped after 24 hours, so something was wrong. We see a peak, and we can do quite some stuff to figure out if we actually have problems or not on looking at graphs like that. We have the same for broadcast traffic and for different types. Okay, let's go on. IPv6 traffic. We do have up to 180, 160 megabit per second of IPv6 traffic on the Amsterdam Internet Exchange. These dips every 24 hours are quite interesting because as far as I know by now, I'm still not really sure about that. This traffic is mostly caused by news providers, and these news providers are updating their services every 24 hours, and you cannot fetch any news anymore, so that's why this IPv6 traffic is going down every 24 hours and at the exchange. The next one is an example for member-to-member statistics. Oh, I forgot to mention something. sflow is sampling on the port, and it's only sampling incoming traffic on the port. So that's why I never have in and outgoing traffic. But in that case, if I sample something if I want to map MAC addresses behind two different ports, then the traffic coming in on that port going to this MAC address is sort of the outgoing traffic for the other port, which is going to that side. So we just assume that what's coming in here, going there, is the outgoing traffic for the other way around, and that's why I can show outgoing traffic in graphs like that as well. Yeah, just a couple of examples what we actually see from member graphs. Accuracy. So at some point I was interested in actually having some information about is this stuff accurate or isn't it? The graph on the right is from the counters made by MRTG, and the graph on the left is from sflow by only looking at 1 out of 8K samples. And it is pretty much the same. Was at the same time? It was, or yeah, almost. Usually I have the impression that sflow is always a little bit more, but things like that also depend on packet size distribution and things like that. So when I get one packet, I'm looking at the size, and I just assume that all the 8K-1 samples I haven't seen doing that are the same size. So if the packet size distribution is different than the packet size distribution in the samples I have, that causes errors, of course. It's statistics, so it cannot really do better, but I think it's pretty okay for what we actually want to do with that, because we are not going to, we don't want to do any billing or whatever with that. It's just information to know who's peering with who and what kind of traffic we have. Same thing for one specific interface of one member connected to M6. Also pretty nice because all the dips there and in the middle are exactly the same. So it seems to work pretty well.
I have a quick question for you. You
Sure.
said that you're only looking at incoming traffic.
Yeah, I just said that. sflow is only sampling incoming traffic.
Okay, what would the benefit be of looking also at outgoing traffic?
Sorry?
What would the benefit be of also looking at outgoing traffic?
Benefit?
Would there be one?
I don't really think so, no.
Okay.
No. There's a lot of people are asking when we put these graphs on the website, and a lot of people are asking like, oh, why is that only green? I missed the blue line. They're used to that or something like that. Because it would be, in the end, it would be exactly the same, because what is coming in on one port is going out on the other port again. Or at least it should be like that if the switch is not dropping packets or something. So.
Who has access to these graphs that shows MAC-to-MAC statistics?
The members.
All the members have access to
No,
all?
only the members have access to their specific graphs.
Okay, thank you.
It is, yeah. Of course, people don't want to have their peering information online somewhere, so that's kind of obvious. But to have information about, I mean, if you want to know something about your peering, you always have to have the second party. So, of course, you see your traffic going to a couple of different people, and that's it. On the website publicly we have the broadcast analysis, the multicast analysis, and the IPv6 analysis. That's pretty much it.
here. You mentioned that the blue line should, however, reflect the green graphs. Now we see, rather a far difference between the blue and the green graph.
What?
You mentioned earlier that the blue graph should reflect the green graph, relatively nearly, because
No. The thing is, this green line here, that is incoming traffic for one port on the switch, and the outgoing traffic for that port is coming from all the other different ports.
Okay.
So if I want to have a blue line in that graph, I would have to analyze all the other ports and find only the traffic going to this specific port and going out over that port again. So in that case, it's not that easy to add a blue line to that graph.
Okay, thank you.
But this green and this green is, in the end, the same data, one statistically analyzed with sflow and the other one from the counters and from the interface.
Is there any specific reason why you don't use counter packages to make the traffic statistics?
Sorry, can you repeat your question?
Is there any specific reason why you don't use counter packages to make the traffic statistics? Because you have the counters in the counter packages, so you can do this sort of graph, for example.
And you mean
counter.
distribute it, get a percentage or something like that, and distribute this percentage over the actual value from the counters? Is that what you mean?
No, you said you assume the packet size is always the same to make the analysis how much traffic is going over this specific interface. Yeah. So why you don't use the counter packet from sflow to collect that data and do the sampling of IPv6 and so on with the flow packet?
You could do that as well. That's another possibility. But in the end, when I when I was looking at these graphs, they are accurate enough for our purposes. We don't really have a specific reason why not doing that, but yeah.
Do you see a future where you could do more fine-grained spatial analysis, basically see traffic counters every second and so on, because a lot of platforms don't collect the interface statistics they show via SNMP as often as they would perhaps do via sflow.
5 minutes usually, or
5 minutes usual, or 30 seconds.
The thing is, the bottleneck is not receiving that from the switch. The bottleneck is writing it down, and you have to generate the graphs. And if you want to generate graphs for 500 members, or we have 420 or something like that right now, each second, I don't think that our hot disks will like that.
Well, the only thing you would need to do is if you do this once a second, you would keep the old counter and you would get a 1 second average, and then you just keep the peak 1 second average and present that in the 5 second graph or 5 minute graph. Then you could see a very fine-grained peak. So
just cache it somewhere when the software only add it up if it's bigger, and then.
Because it would be very interesting to see how peaky the traffic is.
That would not be a problem.
No, so that would be a very interesting development to see. Because a lot of things happen very quickly, often 20 milliseconds is a long time in these aspects.
The thing what we're actually working on right now is the first things, the member-to-member stuff and the IPv6 analysis is sort of done, and the next thing is pretty much to replace the MRTG solution we have right now with sflow counter samples. So I'm still working on that.
For RRD tool, how many RRD databases can you update a second?
A second, I don't know exactly, but we are updating right now up to 50,000 RD databases in 7 seconds, 8 seconds, or something like that.
That works. Thanks.
But we have a fast machine. RD tool is kind of nicely integrated in Perl. That makes it a bit easier because it's not really using the same libraries as C, as far as I know. It's a specific Perl library for RD stuff, and that's pretty cool.
Okay.
Yes.
I have a different question about the implementation.
Sorry?
I have a question about the implementation of sflow, because I was thinking about implementing sflow support for another thing.
The implementation software-wise from
Yeah,
my
so-
side or firmware on the switches?
No, I don't care about the switches. I want to implement sflow support in an open source project.
Okay.
Well, but there. So I want to ask you, how do you handle the patent issues from sflow? Because the sflow company or organization holds a patent on sflow, so it's not free, the protocol. And to implement the sflow protocol, I think you have to join the organization and sign something and something like this. So
Okay.
you just don't care and
No,
release it?
the thing is, I think the difference is if you implement a generator for this stuff or a decoder. And the RFC, it is an open standard, and the RFC is out there, so you can just implement. There are a lot of open source decoders for sflow available. So decoding is not the point. Actually, people from this company having the rights on that, the block images we saw in the beginning, it was kind of hard for me to understand this RFC in the beginning. So I started to making this so many bits and so many bits something. And a couple of months ago, the sflow people emailed me if they could put that on their website. So I don't think they're kind of writes something.
So
whatever.
they're willing to support the people writing the software. So
I understand your point. It's the other way around. You want to generate sflow data in your software, of course. I don't know if that makes a difference because I'm working on the other side, so I'm not exactly sure. But I can tell you a couple of things about all these different formats, all these different. Because there are, I haven't really said a lot about that, but you can do also different things besides only providing the whole sampled packet. And there are devices that are not capable of sampling the whole packet, and you can put it into this kind of sflow structure, only providing MAC addresses, IP addresses, or whatever. Okay. We can talk about that later, maybe, if you want to know something about it. Okay. So the Congress. That was the total traffic we did on our core router upstairs in level D. The only thing why I analyzed that is because the MRTG graphs we have are again looking. We had MRTG running on the upstream interfaces, but everything which was traffic inside the building, and you guys know there were a lot of filers and stuff in here, and not everybody was only doing traffic outside the building. So everything which was inside the building was not going through our MRTG graphs. That's why it's kind of interesting to see how much traffic we actually had inside the building the whole time, and not only going to the other side. Still not enough, because actually we had an upstream so that we could have done that to the outside world. Well, anyway. VLAN to VLAN, that's kind of like the MAC to MAC address thing I did at AMSIX. I implemented on the first day, sitting here somewhere in the room, VLAN to VLAN analysis, what was going on between two specific VLANs, which was also kind of, the graphs were pretty empty because mostly the stuff was going either to the one VLAN where all the servers were or to the upstream VLAN. So the graphs were not that interesting, but it was still nice to see what is actually going on. Okay, and one thing I really liked about this Congress is the IPv6 traffic, because we did quite some IPv6 traffic, and in the end, okay, let's go like that. 4.5% maximum of IPv6 traffic here. I don't know if I can relate that to all the Mac users having just IPv6 turned on all the time or whatever, but it was kind of cool, because if you see the other graph showing the whole traffic, it is pretty much the same what AMSIX was doing on IPv6 on the whole platform. So we do have some users here. Yeah, 100, no, 270. Okay, that's a lot. Yeah, that's what you can do with sflow. More questions?
Do you plan to provide application port statistics or something?
Sorry?
Analysis of the applications like IPv4 ports or so?
No, I didn't do that. I just didn't do that because I don't know, because I know exactly. I know from AMSIX customers don't want to see stuff like that. They just don't want to have like, oh, you're doing so much porn and whatever traffic. So I just didn't do that here as well. I'm trying to only look at stuff which is sort of not too compromising for different parties. But of course you could do that, sure.
So suppose you had a magic wand. What else would you like sflow to be supporting?
Sorry?
So if there was like sflow 2, the revenge, you know, what features would sflow have?
Oh, I definitely miss, but it's defined in the RFC already, but it's not in the Foundry hardware we have at AMSIX, support for CPU and memory usage of the device. That's something I really miss. And that could be, for example, on the RX box we have up here, I could really need that for all the specific line card CPUs.
Could you extract it from like SNMP queries?
Yes, we can do that. So it is actually there. They only have to pack it into the structure and send it out with the sflow packet. So I'm sure they can do that somehow. By the way, I should file this feature request for Foundry at some point.
Going back to like your first slide, you said you can only do 1 gig of net flow, which I strongly disagree with. So if you could perhaps say how you came to that figure?
I came to the figure from, I haven't tested it, so I don't know why I did that myself, but I've heard that from people using it and from Cisco engineers actually.
Okay, because if you do sample net flow with... Like
okay, sample net flow is a different, that might be different, because I don't want to say too much about that, because I don't know that exactly, but I know that in sample net flow they still have some kind of a, they are looking at more than they have to, and it is less efficient than sflow.
Okay, yeah, you can do a lot of different stuff because this is layer 3 and layer 4 information if you want to.
That's true as well. On the other hand, sflow is also doing layer 3 stuff. sflow has also...
And NetFlow really doesn't have much of a layer 2 either, so for your application I do agree that sflow is a better thing.
Yeah, you mentioned that you don't store the potentially privacy invading parts of sflow. Is that common, or is that the exception? You don't store the raw sflow data because of privacy problems.
No.
Is that common? Do other ISPs do the same?
Other ISPs don't do that at all, as far as I know.
They don't record it?
I've only seen IXPs. I've only seen Links so far implementing something like that. They stored everything, or they stored a lot in the beginning. That's why I had quite some issues with performance. And now Vienna Internet Exchange is also implementing an sflow solution, but not a lot of IXPs have something like that implemented at all.
And will this change with data retention directives?
The thing is, it is sampled, so you cannot really store, I mean, even if you would store everything, you just don't have the complete picture of data going over there. And you cannot set the sampling rate to 1. I've tried that.
I'll try.
And it's crashing with 2 as well. So.
I think well, I'd like to find out how anonymity systems would react, or how they would be compromised by sampled data. I get the impression it would be a valid attack, but I need to get some data.
Okay, yeah.
I got a question here. What's the difference on the CPU usage on the router if you're using sflow? Does it go up?
Damn, I didn't know that somebody is actually interested in that here. I did a lot of testing about that. Okay, wait. Let me show the graph, because that's actually a cool one. Niels was right that I should have added that. Okay, so I tested the Foundry hardware we have in the lab, and we have a couple of we have a nice traffic generator there, so I could actually generate as much ports as I have on the generator. And I did testing with different packets, with different amount of frames on specific ports and different sampling rates. The graph, it should be somewhere here. Late. Okay, one thing about the RX box. It is a difference between the line card CPUs and the switch CPU. So the sampling of sflow on the Foundry RX8 and RX16 is happening on the line card CPUs. So you only see the line card CPUs going up, if not the weak. Yes. Okay, so that is the CPU load of one specific line card, and I put different amounts of interfaces, 1 gig interfaces, into that one line card with different amount of frames per second and with different sizes. Oh, I have another graph for that. They are all small frames. Okay, small frames, then we have more of them going through, so that's why this graph is even worse. And on the bottom we have the sampling rate. But the amount of which one is the highest? 16 interfaces there. The light blue line is the maximum I've done there. 16 interfaces on one blade with 1,300,000 something frames per second. So that one here. But if you count that up to 16 interfaces, you get an amount of 35 million frames per second on one line card. This is what we do on the whole exchange. So that was really a high load test, and you cannot have something like that in the end. At least I don't think so. But we still decided to go for 8K as a sampling rate because it looked kind of, safe, even if it's really high load on this blade.
Thanks.
But that's somewhere online, so if somebody needs test results for Foundry RX boxes, go ahead. Okay. Right on time, or?